Good afternoon, everybody. Today is Monday, September 12th, 2022. My name is Mr. Meeseeks, and I'm here to help you learn Elixir. So today we're going to be working on the syllabus. So we have unlocked AST, which stands for Abstract Syntax Tree. So let's break into that. The abstract syntax tree, also commonly shortened as AST, also called a quoted expression, is a way to represent code as data. Each node in the AST is a 3-element tuple. For example, here, AST representation of 2 plus 3 is a 3-element tuple, with the first element being a atom of a plus sign, the second being a list, and the third element being the list of arguments. In this case, the integer values 2 and 3. The first element is an atom is the operation. The second element is a keyword list, is the metadata. The third element is a list of arguments, which contains other nodes. Literal values such as integers, atoms, and strings are represented in the AST as themselves, and instead of a 3-element tuple. Turning code into AST. So changing Elixir code to ASTs and ASTs back into code is part of the standard library. You can find functions for working with ASTs in the module code to change a string with code to an AST, and macro to traverse the AST or change it to a string. Note that all the functions in the standard library use the name quoted to mean the AST, short for quoted expression. The special form for turning code into an AST is called quote. It accepts a code block and returns its AST. For example, you can put a quote block around 2 plus 3 minus 1, and you'll get this value structure back, which is basically the minus, and then inside of that is the first element, which itself is an AST block, and then where basically you're going to do addition first, and then you'll do subtraction afterwards. So the ability to represent code as an AST is at the heart of metaprogramming in Elixir. Macros, which is a way to write Elixir code that produces Elixir code, work by returning ASTs as output. Another use case for ASTs is static code analysis, like Exercism's own tool, the Analyzer, which you might already know as the little bot that leaves comments on your solution. So, yeah, Elixir, I think, more than other languages, is actually really built towards metaprogramming. And in fact, once you get over the hump, you'll kind of discover that Elixir itself is like, when it comes to like the keywords, is actually a really small language. Most of Elixir is built on top of macros, which uses AST under the hood. And yeah, I mean, day to day, you may not write a lot of AST stuff yourself, but it is helpful to have an appreciation for what it is and how it works, particularly when it comes to looking at the source code for Elixir. If you're ever curious how something works, or other languages that you run into, other libraries that you run into, like Ecto, that use a lot of macros themselves. So that is the concept. Now the exercise is called Top Secret. You're part of a task force fighting against corporate espionage. You have a secret informer at Shady Company X, which you suspect of stealing secrets from its competitors. Your informer, Agent X, is an Elixir developer. She is encoding secret messages in her code. To decode her secret messages, take all functions, public and private, in the order they're defined in. For each function, take the first n characters from its name, where n is the functionality. Wow, okay. So, all right, let's just download this and we'll just get started here. So we'll download our exercise. Curious if I hold this. Yeah, that opens it in. I wonder. Yeah. I was kind of curious if there was a way just to like the CD into it by clicking it in the terminal, but whatever. All right, we're going to open this in VS Code. And so that is our source file. And we'll put our test file up here. And we'll put our README down here. use the Explorer. All right. So let's show you here. Turn code into data. Implement to AST function. It should take a string with Elixir code and return its AST. Okay. Let me look here. Quote do, and that you can do that. So they mentioned the code module and the macro. So let's look at the docs for code. Or that's this module complements Erlang's code module. Okay. For functions to manipulate XRSTs using the macro module. Work compiled, start, stop, trace. String to quoted converts the given string to its quoted form. That looks kind of like what we want. String to quoted takes a character list and keywords, and then file name to reported. Oh, these are just all options. Let's try this. So let's say code. What was it called again? String to quoted. And just pass it the string. And let's run this test to see if this works. So it does work. Cool. Yeah, that works. I'm curious, like, to look at the test here. So we'll say handles a small code snippet. So given this small chunk of code, the expectation is that when you call topsecret.toAST, you pass it this string, you'll get back this AST block. So it'll basically be line number. Line is just the metadata. That's cool. That's neat. Okay. Not gonna answer. All right. The phone off. We will return. Number 2. Actually, let me make this small again. Number 2. Parse a single AST node. Implement decode secret message part function. It should take an AST node and an accumulator for the secret message, a list. It should return a tuple with the AST node unchanged as the first element and the accumulator as the second element. If the operation of the AST node is defining a function def or define p, prepend the function name, change to a string to the accumulator. If the operation is something else, return the accumulator unchanged. Wow. Okay. This is this is abstract for sure. Okay. So given this string, in this accumulator, it's supposed to put cat in front of day, And for example, if you were to give it this, it would just return the AST node and the function doesn't need to do any recursive calls to check the whole AST, only the given node. The built-in tools in the step. Okay. Let me read this again. It should take an AST node and an accumulator for the secret message list. It should return a tuple. If the operation of the AST node is defining a function, def or defp, prepend the function name. Okay. So, okay. So let's take a look at this, one of these tests. I'm going to get my test down here, just so we can kind of see what this looks like a little bit. So this is implementing a function called delete. And so the first node is going to be a def module, and then it's going to have a spec, then it's going to have define. So what we want is we want to pattern match anything that is def. Well, what do you call that first element? What did they say? First element in Atom is the operation. Okay, so we'll call that operation, metadata, and then arguments. Okay. And let's say when operation is in a list, so we're going to like say def or defp, it'll do this thing. Otherwise, we'll have a second otherwise we'll have a second backup function that'll capture it. So what are we supposed to do if so in this case, line 4 is the metadata. Delete. So deletes the name. Oh boy. All right. So if they pass in the block, def will be the operation, and then arguments will be this chunky thing. Does that's metadata, and then that's the arguments list. Okay. It should take an AST node and an accumulator for the secret message. A list. It should return a tuple with the AST node unchanged as the first element. Okay. So this is going to be node. It's going to return node and the accumulator. If the AST node is defining a function, prepend, actually I'm just going to say this node. This is actually just going to be node accumulator. This one's actually going to be the accumulator. The operation of the AST is defining a function, defp or def or defp. Prepend the function name. Change to a string to accumulate. So how do you get the I mean, it's in arguments. Function name is arguments. Probably that's going to be a list. So the function call, this function is called, the node is passed in, and we immediately deconstruct through pattern matching. We grab the operation, we grab the metadata, which I don't think we're actually going to use. Then we grab the arguments. The arguments being this list. This list itself is a list of nodes. So it's not a tuple. List.first. Accumulator equals I think what we want, and then we'll put that on the and we can probably just, this is not happy. I'm not doing something right. Find end. Oh, I don't need an end here. All right, let me run the test to see. Oh, did I do part one? No, I'm doing part one right now. All right, so that's all task one. We're done task one. This is task two, task three. We'll run all these, but not all these are gonna pass. Run that cursor. I'm running one test. Oh. Why does it think where my cursor is? 78. Decode secret message part 2. Decode secret message 1. What is that's relative to task 5. All right, I'm just gonna run them all. It's weird. I don't know why the tests are organized like this, or I'm like doing something wrong. Let me just run this test. Test a cursor. Line 80. It fails. Function arity affects message part. Add. Something's weird. 39. Something's weird with the line numbers. They're all off a little. All right, let's see what's failing here. Function arity affects message part length. This test is failing. Function arity affects message part length. So given def, adjust, do scale, and turn it into a string. To AST. Accumulator starts with re. Assert. Add. D. What? Why would it not be adjust? I'm missing something. And this is like, I'm missing something with the instructions. Implement. It should take an AST node and an accumulator for the secret message list. It should return a tuple with the AST node unchanged as the first element and the accumulator as the second element. If the operation of the AST node is defining a function, prepend the function name changed to a string to the accumulator. If the operation is something else, return the accumulator unchanged. This function doesn't need to do any recursive checks, only the given node. We will traverse the whole AST and then build a last step. Why, if you are given a function name of adjust? Why would you be expecting the string AD? Task 3. Am I still on task? Yeah, I am out. This is where I'm messing up because like this is related to task 3. And I just did task 2. All right. I'm gonna stop here. Extend decode secret message part. If the operation AST node is defining a function, don't return the whole function name. Instead, check the function's arity and return only the first n characters from the name where n is the arity. So for example, if you were given a AST where they were defining a function called cat and it had 2 arguments, you would only return the first 2 letters. Whereas if you had cat and it had 0, you would return 0. Okay, so now we need the number of arguments. I'm going to call these node arguments just for a little help of expression. I'm going to call these function arguments, right? And then for the string, for the, what do you want to call this? The secret message. If you'll want the first n characters of it. So let's do this. Let's say function name atom to string, and then we'll basically take first. So string dot like, what is the what's a good string function to use for this kind of thing? Let's say chunk. Chunk sounds interesting. First, choose the first grapheme. Match. Padding. I don't want padding. Place. I don't want place. Slice. Slice sounds interesting. That looks pretty attractive. So slice. Give an elixir. Give me 1 to 3. I think that's what we want. String.slice. Slice. And then the range is going to be 0 dot dot whatever the length is. So to capture equals list dot, well, you can function arguments, I think. Extra quote there. Yeah, from there. Secret needs to be spelled right. Okay. All right, let's try this one again. 80. Now it fails. We functionality affects message per length. Okay. We're just gonna test this function. Test at cursor, and that passes. And run a cursor. Fail. Probably because oh. Line 132. I don't know why it says line 132. Because that's not, I don't know why these line numbers are off. Yeah, like that's not where the assert happens. It's not where the test is declared. 139, like this is where the assert is. It's like 2 numbers off. All right, so let's take a look at this. So that one passes. This one is not. So given a just, I want to capture. Let's capture this. There's actually a new kernel debug command, which is in Elixir 1.14. I don't have that installed for this yet, so use the older one. So when this ran this, there's 2. J. What are the A and B? Why am I saying A and B? This is so weird. Like, something is really wrong with the cursor placement. Okay. So arguments was an empty list. There was 0 to capture. Okay, so like if I do string dot slice and I say A, B, C, D, and I say 0 dot dot 0, that returns A. Okay. So it should only do that if let's look at the documentation again. 1 to 3, 1 to 10. You can use dot dot as a shortcut for 0 and 1, return a whole string. I wonder if we could do that. So like, imagine we said start at 0, give me 0. That would give you an empty string. That's probably closer to what we want. Alright. String. Actually, we have this in pasteboard, so we'll get rid of that. And then this will. And cool, that passes. What else? 3, 3, 4. Do any 4 yet? 4 is the last step. So that was 3. Fix the decoding for function with guards. Extend. Make sure the function's name and arity is correctly detected for function definitions that guard. 4 and 5. Okay. Fix the decoding. If I run that cursor, what did it run? It ran. Yeah, it ran. It doesn't run. It's not running the right one. Damn it. If I test it in here, it'll run the right one, right? Yeah. That's so. Alright. So, what do we need? Extend, decode secret message, but make sure the function's name and arity is correctly detected for function definitions that guards. Use guards. Alright, let's see what this even looks like. IO inspect, we're going to inspect the entire node. And we're doing number 4, right? So let's test here. And let's see what it looks like. Define. So in this case, when is the first element of the node argument? Why would when impact capture of the argument count? Oh, it's I guess because we're making an assumption that like we're doing a thing here where it's like first. Can't do that. Ugh, this is getting clunky. Okay. Make sure the function's name and RD is correctly detected. I mean, the way I would do this is I'd probably implement a private function, right? It just says like length to capture, and I would pass it in the argument. Found a when, then it would like do a recursion. Define p length to capture. It's going to take the node arguments and it's going to return the thing. So like we'll do a pattern match for the first implementation of this. And we'll say when node arguments. So when the operation is a when, metadata would you say nodes? I think it would just say nodes there. And then otherwise, we would kind of do what we do now, which is to say grab the function name and the function arguments based off of the first you can't length to capture. It would just be node, right? Not plural. I don't like this. This is weird. So given a really messing. We no longer have there. What do I want to do here? I think you need to capture it. Function name. I don't like my naming on this. How do they describe it? The first element is the operation. The second element is a keyword list, is the metadata. The third element is a list of arguments which contain other nodes. I'm just going to say nodes. So a node comes in, it is broken up. You have the operation, the metadata, and then the other nodes. When the operation is def or def p, then we're going to then we want to capture length to capture. I don't know what to call this. Extract components. I don't even know. Extract message components. I mean, that's what it's doing. And so this is going to you're going to get passed in the node, the entire node, right? Actually, no. You want the nodes. Can you always make the assumption that you just want the first element of that? It's very tough because, like, no, I don't want to answer that phone call. Because you're not given a lot of examples of this thing. So, like, in this case, this is a list of nodes, and it's just one. I mean, I think you can say list dot first and just always grab the first one because we always expect a single one. Because again, this isn't like we're not doing recursion up here. I don't know. So this is going to get a single node from the nodes. Yeah, it's tough to use that term. I don't like the word nodes, so call it. Third element is a list of arguments which contains other nodes. It's not that. Oh, it's because we captured here. Oh, there. Okay. So this thing's gonna take in a node operation. We're gonna pattern match with a guard. It says if the operation is def or def p, we're gonna do this thing. Otherwise, we're just gonna. if it is a def or def p, we're gonna make an assumption that this argument is always going to be a list of one element. And we'll grab the first element, which is going to be the node describing. It's either going to be a when or it's going to be the argument list. And in this case, we're going to capture arguments. We don't need the word there. If it's when, then we're just going to call this again with whatever the argument list was. Again, we need first. And then this one is going to be function name, the function arguments. Let's keep it. Oh, I don't even need that. Right? Because this is just going to be a node. This is getting deep. Let's try to run our test. That passes. Wow, that is that's surprising. All right, so it's gonna accept the AST. If it's def or def p, it'll grab the first. It'll extract the function name and the length to capture, and then it'll generate whatever the secret was. Okay. All right, let's keep on moving. Let's see if this one passes. Run a cursor. That passes. And then we got our next one. Decode secret message. 5. Implement decode secret message function. It should take a string with the Elixir code and return the secret message as a string decoded from all function definitions found in the code. Make sure to reuse functions derived in the previous steps. So, given this blob of stuff, you're supposed to know that it's by because it implements a function called busy. It's got 2, so you take bu. Then it has a function named yesterday, and so it's only got 1, so you take y. It'll be by. Okay. Alrighty. Alright, we're going to jump back in here. I'm going to cut a whole bunch of that out and catch up here. So I've been working on this. You can see all the tests are passing now. And now I'm going to walk through how I solved it. And I solved it by cheating because that's how everybody solves stuff. So I was looking around at some of the other solutions to this that were posted on the Elixir exhort that Exercism ran because people were sharing their solutions for that. And so they shared this, the big aha moment was this macro.prewalk function, which you can look at and it'll say performs a depth first pre-order traversal of quoted expressions using an accumulator, returns a tuple where the first element is a new AST where each node is the result of invoking function on each corresponding node, and the second one is the final accumulator. Wow. And for us, that basically means we can pass it an AST and it'll walk it. And as it's walking it, it's going to accumulate a message. And so the way we're going to do this is with a list. And so for each node in this AST traversal, it's going to run our function, decode secret message part. And at the end of this, it's going to have some brand new AST, which we don't really care about. And then it's going to have our list, which is the message. Then we're going to take that list, we're going to reverse it, and then we're going to join it, and that will be our final message. And that'll make all the tests passed. So, and that'll even solve for things like here at the end, where you need to decode a secret message from multiple modules. So like it'll parse that entire tree, which some early parts of my implementation were not working with that. So that fixes that. The second thing I had to fix was there was one of these tests which was failing because see if I can find it. I think it was this one. Yeah, I think it was this one. Functionality 0, no parentheses results in empty string. And this is breaking some of my code. And I was looking around at the solutions that some other people had done, and so I kind of worked it into this. So historically, we had this function called like extract, and it was doing a lot of logic. And so this one was a little bit more straightforward. So it says get function name, and it passes in the arguments. It returns a tuple, which is name and arguments. And this is important because sometimes, and you can see how our implementation here of get function name, so sometimes when, well, first we'll pattern match against the when operation, and that's just gonna loop again to solve for that problem. But the other the problem you're gonna run to is with this case here, like when the arguments are an atom, then it really needs to return an empty list. Otherwise, you'd get like nil here. It's weird. But that's basically what it's solving for. Like through pattern matching, we're capturing the arguments. When the arguments are a list, we're just doing a pass through. When they're an atom, we're fabricating an empty list. And we're fabricating an empty list so that later, when we want to do the string slicing, we have a list to run into length. And so in the case of an empty string, in the case of an empty list, string.slice 0 comes 0 will just not do anything, which is what we wanted. And so that makes everything pass. This one was a bear. So we're going to submit it. And boy, do I hope the analyzer is happy with our solution. The analyzer is. And all right, cool. So we're gonna just mark this as complete. Well, no. We want to look at the community solutions. I want to see how other people have solved this. So that's understandable. Get function name and args. Arity. Yeah, they did that too. That's basically the same solution. Okay. Let's look at this one. So this one, yeah, this is like, yeah, they all did macro.prewalk. Did they teach us about prewalk? I mean, I know this is the thing, like in the concept doc, like they mentioned that there is a code module and they mentioned that there is a macro module. But they never mentioned prewalk, and like, man, that like not even without a pointer to that, like I was totally lost. Yeah, they're solving this with a lot of pattern matches and functions that, I mean, technically work, but like they just don't read well. Like they read like scary gibberish. Let's see if anybody else has a lot of stars. This one, 4 stars. Yeah, they're just solving like that. Okay. Well, that's gonna finish it up. I'm gonna mark this as complete. I'm gonna publish my iteration, and I've learned AST. LOL. Wow. Okay, so this is gonna be an extremely long video that I am going to edit aggressively because there's no reason for you guys to sit there and watch me scratch my head for so long. But Anyway, hope you watched and enjoyed the show, the video. If you have any questions or feedback, definitely let me know. Other than that, thanks a lot for watching, and I will see you next time. Bye-bye.